Welcome back to the ROS lectures. This is part 2, and in this lecture we're going to look at communication and some terminology. So we're going to start with nodes. Basically a node is just a process or program that does some action, and these nodes are meant to be designed such that they only do small actions, and when combined will make up an entire robot system. By doing this, it encourages reusability of nodes for a vast array of different systems. So for example, a single node may collect data from some sensor, whilst another does the conversion of that sensor data. Furthermore, by having small nodes, if one crashes, it is isolated to a single node. Okay, so you can fix that particular node when you need to, rather than trying to fix the whole system. Now, ROS nodes use a ROS client library to communicate with each other using topics, services, and parameters, which we'll look at in this lecture. Now, nodes also have a name and a type. So a node can act as a publisher, a subscriber, a service server, a service client, an action client, and also an action server. When a node is first executed, the node registers its information, including its name, type, address, port number, to the master, and we'll talk about the master shortly. Nodes use a TCP connection between each other, which gives direct communication between nodes, independent of the master. The nodes have a URI address and port number, and we use the IP address that we saw in the previous lecture for this URI address. And the port number is just set to an arbitrary unique value. So now let's have a look at the master. So basically the master acts as a name server for node-to-node communications and connections. So every ROS system needs a running master. And when the master is run, you can register the name of each node and get information when needed. Now, if you don't have a master, then nodes cannot find other nodes, and they cannot make connection between other nodes, nor can they communicate between each other. So you must have a master for every system. Now, the slave nodes can access the master only when they need to register their own information, or when they need to request information about other nodes, meaning that the master is used by nodes to identify themselves or to know where to find other nodes. With this, the master does not maintain connectivity. Now, this might be strange to not have this constant connectivity maintained, but it means that ROS can be used in very large and complex environments, so it's only connected to when it's needed. Now, to run the master, the command ROS core is used, and we'll look at that when we do some examples in one of the future lectures. Alright, what have we got next? Alright, next we have topics. So topics are name buses, which are used by nodes to communicate with each other. Topics that are published, so meaning that they're sent, and you've also got topics that are subscribed to, so meaning received. And these topics that are published and subscribed by nodes are all anonymous. So this means the nodes are not connected with which node they are communicating, rather the data of the topic. Further, topics are unidirectional, meaning one way, and they're also streaming, meaning that there's a constant flow of data. The publisher node, before sending its topic, has to register it with the master. Subscriber nodes that want to receive the topic from particular publisher nodes need to get the name of the topic that was registered in the master. So you can see here in the slides that the subscriber is getting information about the topic from the publisher, and you can have multiple subscribers subscribe to the same topic from a publisher. The next thing we'll look at is a service. So a service, on the other hand, is a synchronous bidirectional communication between a service client that makes a request for information regarding a particular task and a service server that responds to that request. So this means that we can perform two-way communication using services. However, a service is a one-time message communication. So it's not streaming out data like a topic, rather it's one time. So basically what happens is a client will make a request, okay, to do some action or perform some calculation or some task, and then it waits for the response from the server, and then the server sends the response back, as shown in the slides here. Now, in some cases, there may be a delay in the time that it takes for a service request and response. In these cases, a user may want the ability to cancel the request during the execution, or they might want to just be able to get some feedback about how the request is progressing. So the Action Lib package provides tools to create servers that execute long-running goals that can be preempted. The actual structure of an action file is similar to that of a service, however, feedback is also added. So basically how this works is the client requests the server for some goal, okay? Similar to a request, okay, but for some goal. So for example, let's say we want to scan some object. The client then can receive regular feedback of how that's going. So it can inform the client of progress. So this might be the time until completion. So for our scanning of an object, it'll tell us how long until that is done. Then the result is sent once the goal is done by the server, which would be the result of our scan in our example. Now, at any point in time before the goal is sent, the client can send a request to cancel the operation. Alright. Further, in ROS, we have parameters. So these are the parameters used in the node, and default values are set in the parameter and can be read or written if necessary, and they can also be modified in real time, which is kind of handy. So these could be parameters like the minimum motor speed or the USB port number, and you can change these while the node is running. So now we'll have a look at the message communication flow. So the first thing that we have to do is run the master, and this is done using the command ROS core. We then might create a subscriber node and run it. And the first thing that will happen is that when we run this subscriber node, it will publish its information to the master. So its name, its type, etc. The next thing that we'll do is we'll run a publisher node, and this will do the same thing. So it will register all its information with the ROS master. From there, the subscriber node needs the information of the publisher node such that it can connect to its topic. So the master distributes publisher information for the subscribers that want to connect to that publisher. And we can see that here in the slides. So this subscriber, now that it has this information about this publisher node and it knows it exists, it can now send a connection request to the publisher node. From here, the publisher node can send a connection response to acknowledge, and then from there, there is a connection between them. And after this, we then can get the information from the publisher node to the subscriber node via a topic, and this is just our message transmission. And because this is a topic, this will stream constantly, and it is only one-way communication. As said before, nodes can communicate via topics, services, and actions. The nodes do this by passing messages to the topic, service, or action. Simply, a message is a collection of data in set fields. A message can use standard primitive types that are used in most programming languages, such as integers, floats, booleans. Furthermore, you can use arrays and structures, and messages can contain other messages. So the first message type we're going to look at is messages that are in the .msg format. And these are used for topics. So .msg can include fields as to send data, and also include constants that can be used to interpret the data that is sent. Remember, topics only send data, okay? It's one-way communication. So each field needs a field type, and these types can be any of the inbuilt types that are shown here on the slides. They can also be another message description, arrays, or a special header type. So the special header type just includes the sequence ID and the time, which can be very helpful with your message communication. Now, constants need a field type and also a value. Okay, so you need to give your constants a value. So a very, very simple message file or .msg file is shown in the slide here. So we have the X field with the field type of an integer that is 32 bits, which you should all be familiar with using a couple of different programming languages. And we also have the constant Y with the type of a string and the value of ROS. The next message format we'll look at is the .srv format. And this is used for services. So these can contain fields and constants just like the .msg files, but the files themselves are separated into two parts, the request and the response. So if we remember back, for service clients, they send a request and then they get a response from the service server. So there's two parts to the communication. So here we have an example of a .srv message, and you'll see that the difference is the addition of the 3 hyphens in the middle. So this basically just separates the request from the response. So the top bit here, the X and Y, is going to be part of the request, so the information sending to the server. And then the part at the bottom is the response. So this is the response the client gets back, which is our Z here. Okay, and we can have lots of things here. It doesn't have to be as simple as this. Lastly, we're going to look at the .action format. And this is used by actions. Once again, this is very similar to the other message formats, but now there's 3 different sections. And the first section is the goal, the second the result, and the third being the feedback, as we talked about when we talked about actions. Alright then, so this concludes part 2 of the ROS lecture. and in this lecture we looked at communication in ROS, and in the next lecture we'll start looking at packages and some examples.